All right, so where we left off, okay, we're talking about acid-base reactions, okay, and let's just look at a simple acid-base reaction. Sodium hydroxide is our strong base. We're going to add it to HCl, which is our strong acid. If you don't remember this, review the last set of videos and slides, parts of the slides. All right, we're going to get out. It's a double displacement, NaCl and water. This is known as a neutralization reaction because you're taking an acid and its property, which is that hydrogen. You're taking a hydroxide, which is that property right there, and you're making a neutral substance, which is water right here. Now, when we looked at calculating theoretical yields, let's say I want to know how much water I'm going to make from this reaction. What we did is we took the grams of what we know, let's try that again here. And then over here we did the molar mass of what I know. The grams on the bottom and 1 mole on top. Okay. Then we did the mole ratio from our balanced equation. All right. So known on the bottom and the want on the top. And we have the molar mass of what I want with 1 mole on the bottom and the grams on top. Okay. And you were given like grams of sodium hydroxide and grams of HCl and so on and so forth. And you had to find your limiting reagent by converting to the least number of moles and figuring all of that out. Well, one second, please. All right, so we would give you grams of sodium hydroxide, we'd give you grams of HCl, and we'd be able to figure all that out. Well, the thing is, these are aqueous solutions. You would never weigh out a liquid or an aqueous solution specifically on a balance. You never weigh out a liquid. If you needed the grams of a liquid, you use the density. And if you need to figure out how much aqueous solution you're adding, you should know what the concentration is. So what if this said you took 30 mils of 0.5 molar sodium hydroxide and you added it to 20 mils of 0.6 molar HCl, and I wanted to know how many grams of water I got out. Now granted, you wouldn't weigh it in grams, you'd figure out the volume later, but let's say I wanted to know that. Okay? And Kelsey, this kind of asks or answers your question that you asked me in an email with the lab. What does the 0.5 and the 0.3 have to do with anything? Well, it has nothing to do with balancing your equation. It has nothing to do with writing your complete and net ionic equation. It would have to deal with if you're trying to predict how much product you were going to make. So I don't have grams, but I need to figure out what my limiting reagent is. What I do have is a molarity, and I have a volume. And if we remember our molarity formula, molarity equals moles per liter, I should be able to figure out the moles of each reactant and be able to start right here on our table. So for NaOH, it would be 0.5 equals 0.030 over X, which would give us 0.015 moles of NaOH that we are going to use. We would do the same thing with HCl. 0.6 equals 0.020 like so over X. And we'd figure out the moles of HCl we're using. Okay, so let's see, should be 0.0 times. All right, 0.012. All right. I don't know why I couldn't do that one in my head. Moles of HCl. Now, we need to figure out which is our limiting reagent. So we got to convert it to the product using our mole ratio. It happens to be a 1-to-1 relationship. 1 mole NaOH to 1 mole of water. Same thing down here. So this answer is actually our moles of water. It's a 1-to-1 relationship. So this is our limiting reagent. And we would use that to find the mass of our water. But the reality of the situation is we really don't ever use this to find the mass of the water or the mass of the salt or anything like that. Okay. Any questions so far of what I did or where I found the numbers? So it's basically doing the same thing, but instead of being given grams, you're able to find the moles and start here. This one's 0.03. That's a 3. This is a 2. And it comes from there. So where do we really use this information? We use this information in something called titrations. Okay. And the first step in a titration is to write a balanced equation out. It's on back order until May, so useless. Amazon's only shipping essentials. They're slowing down on everything else. So this is what we got to deal with. I could either do it this way or I could just post videos online. Best I can do. So first step to a titration. What a titration is essentially reacting enough acid and base together to completely neutralize it. Now maybe you did one in high school, I don't know, but what you do is you take a burette, which is a way of measuring a volume of something. It reads backwards. Goes 50 to 0. Okay. And we would fill this to the top. And the way we would read this is, this would be 50 mils. Even though on the burette it says 0 mils, we read it that there's 50 mils in there. And this is the 0 mil mark. Like so. We'd fill it with some concentration of base. So we'd have a known concentration, let's say it's 1.0 molar sodium hydroxide sitting in our burette. Let's say down in our container, we have some unknown concentration of HCl. And let's say we have 20 mils of it. And I want to know what is the concentration of my HCl. So what we do to figure this out is known as a titration. And we essentially add base to the acid until it's completely neutralized. Well, there's two ways of doing that. One, you get a pH meter, you put the pH meter in, and you wait till you hit 7. The other way is to use an indicator. And the indicator that we normally use is phenolphthalein. Phenolphthalein is colorless in an acid and turns pink in a slightly basic solution. Okay. So, we would continue to add base into the acid until we got a pink color. When that pink color shows up, we then take a reading on our burette. And let's say the volume level drops from 50 mils down to 20 mils, because again, we read this backwards. So we added 30 mils were added. Okay? When that pink color shows up, we call that the end point or equivalency point. Okay. So how do I figure out the concentration of HCl from this data up here? So I added 30 mils of 1 molar sodium hydroxide to 20 mils of unknown HCl. All right, so I want to know what is the molarity of HCl. In order to do so, I need the volume and I need the moles. Well, the first thing is the volume. They gave that to me. What they didn't give me is the moles. I need to figure out the moles of HCl, and I do that from my equation. How many moles of HCl are there? Well, it took 30 mils of 1 molar sodium hydroxide to react with the 20 mils of HCl. Well, the first thing I could figure out, I have a concentration and a volume of NaOH. Okay. That means that I added 0.030, by cross multiplying here, moles of NaOH. Now, I need to convert that to HCl. Now, it just so happens that my example is a 1-to-1 relationship. That's not always the case. So step 1, write out an equation. Step 2, find your moles of NaOH. Step 3, convert your base to the acid moles. So my relationship's 1-to-1. For every 1 mole of NaOH, it reacts with 1 mole of HCl. So that means that there must have been this many moles of HCl sitting in the container. Step 4, figure out your molarity. They'll have to give you a volume. You did the math to figure out your molarity. Plug that in there and do the math, which should be 0.15. 1.5, I mean. My math, my decimal off. And that's how you do a titration. And that's going to be one of your experiments where you're going to be given data where you lost, Elena. Endpoint or equivalence point. Your book calls it the equivalence point, also known as the endpoint. The equivalence point is the point at which enough base is added to the acid, and the indicator marks the endpoint of the reaction. Step 3 is converting your moles of base to moles of acid using your balanced equation. So if the problem said something like, and we'll do another one after this. All right, let's try another one. See if it clears it up. What if we said $25 mils of unknown concentration sulfuric acid, okay, is titrated with 40 mils of 2 molar sodium hydroxide. Okay, to reach the end point. And we want to find the concentration of the H2SO4. Okay. So you would do a titration. You'd have the H2SO4 sitting in a beaker. You'd have your burette filled with your sodium hydroxide. You'd let the sodium hydroxide go in until you got the pink color. So step one is to write a balanced equation out. Write a balanced equation of what's going on. So sodium hydroxide is reacting with H2SO4 to give us, and we're going to switch partners. Okay. Sodium sulfate, which is going to be Na2SO4, because sulfate is a -2, sodium's a +1, and water, HOH. Okay, now we need to balance it. We're going to balance it. 2 sodiums, I need a 2 here. 2 hydrogens, 2 hydroxides, I need a 2 here. And the reason I write it out as HOH is because it makes it a lot easier to balance seeing the OH and the H's. Because I could say 2 OHs, 2 OHs. All right, everybody with me so far? All right, step 2. Figure out how many moles of base. How many moles of base were added? Okay? So we're looking to figure out the moles of base. I know I have 2 molar. I don't know the moles. And again, I'm going to put it up here. Molarity is moles per liter. I don't know the moles, but I do know the molarity, and I do know the volume. Make sure you convert it to liters. So when I do the math here, 2 times 0.04, I get 0.080 moles of sodium hydroxide. Okay. Everybody good with this part? Okay. Part 3 is find the moles of acid. And the way we do that is we take our moles of base and convert it to the acid using the balanced equation. So, I've got 0.080 moles of NaOH. What's my relationship? 2 NaOHs for every 1 H2SO4. And I know I should have aqueous here, and aqueous here, and aqueous here, and liquid here. But our conversion's 2 to 1. So for every 2 moles of NaOH, it reacts with 1 mole of H2SO4. Moles of NaOH cancel out. Do the math. We have 0.040 moles of H2SO4. Are we good there? How to find our moles of acid? Rocking my Luzerne County Community College sweats, man. All right, then step 4 is to find your concentration of the acid. I know the moles. I just calculated them. 0.040. I know the volume. They gave it to me up here. 0.025. And now I do the math. 0.04 divided by 0.025. And I get an answer that my sulfuric acid is 1.6 molar. So in 4 steps, you can do a titration. The key is balancing out your equation, figuring out the moles of base, using the balanced equation and the moles of base to find your moles of acid, and then plugging it into the formula. Got it. So if you want to see what it really looks like, we can look at the slides, and this is what it would look like if you were doing the titration in lab. That's actually too dark of a pink color for my liking. Okay. And here's the setup that would be there. You'd put an unknown acid in. And your base would be in the burette. And you'd get this pink color knowing you're at the end, and you would read the final volume. And this is just what's going on the atomic scale. You can try sample problem, and I'll end the show so you can see the problem. Sample problem 4.6. Okay, sample problem 4.6 is a good example, plus I'll give you homework on it. Okay. I'm sorry if I did confuse you. All right. Hopefully that cleared it up. Okay. All right. Questions on titrations? Now, there's a section in the notes about conjugate acid bases, Bronsted-Lowry, and stuff like that that I normally cover if we're in the classroom setting. Just because we are doing this at a distance, I don't want to overload you with information, especially since you'll be taking the exam online. Okay? We do Bronsted-Lowry and conjugate acid base pairs in chapter 18 in Gen Chem 2, so you're not going to miss out on it. It's just that I don't want to overload. Okay. We did talk about that acid-base reaction. Now, I'm not done with lecture, but let me give you homework just to keep everything together. Let me give you homework on the acid-base reactions and stuff like that. Okay, and using molarity to do conversions. All right, and theoretical yield. So, I'm actually going to make two separate videos, one on the titration stuff and one on redox, so that they're two different topics. Okay, so that's why I'm going to give you the homework on this right now. So homework on this that covers essentially converting molarity to products and things like that. So we're on page 198. .47 to 4.50. Those aren't acid-base. They're just regular problems that do molarity conversions to find product, theoretical yields. And then acid-base stuff looks like 4.69 to 4.72. And then that practice problem from the slides, practice problem 4.6. Slides. Okay, so that's the homework that covers acid-base stuff.